So let's look into F test. F test is F distribution is pretty much chi over degrees of freedom chi 1 over degrees of freedom 1, so which is one categorical. I might recall the chi test, and denominator is the same, chi 2. So a major application of those of F test is a variance of two populations. So one of the example is comparative variance, where the null hypothesis is that the variance are equal. So the data 1, data 2, with with mean of x1, x2 as variance of s1 square, s2 square, degrees of freedom, n1 minus 1, and 2 minus 1. You can have f square, f as s1 square over s2 square, and then you can check on the table of x f df1 or df2. It also sometimes mention a df numerator and the df denominator, and you can check the alpha desired alpha, which is interval of confidence. And another application is NOVA, which is an analysis of variance. The null hypothesis of such application if is difference between the groups. There's a difference between the groups. So let's see. There's like a multiple group of where the data, each groups of data have a average of xi, and then the obviously the total average of every single group will be the weighted normalized mean of each group. So we calculate the sums of the square in between data. So we can just calculate the group I minus the total overall average, and we can normalize it by the degrees of freedom in between, which is the number of the group minus 1. And then we can calculate the similar thing, sum of the square within the group, which is so pretty much every element of the data I within group data I within group J, and minus the mean of the group J. And then we normalize it by the degrees of freedom of within. Within can be calculated as the sum of the total number of data within each group, and minus total number of group. And then we can the f will be calculated as a mean square within square between divided by square within, and then the degrees of freedom are like that, are just degrees of freedom between and degrees of freedom within. Here's the distribution. Degrees of freedom of 1, 1, 3, 3, 1, 1, 3, 3. Importantly, is worth noting. So df1, df2. Intuitively, you can imagine there's got to be some type of interesting relations between by flipping it, which it is. So we have this relations. Just imagine you're flipping everything in terms of in terms of this, you just flip those two and flip degrees of freedom, and then thus you will essentially flip this, thus the distribution will change, which makes sense.